Hi folks, this is the corn, soybean, and wheat disease update for 2021. 2020 was a challenging year in many respects, as we well know. Crops also experienced a gamut of conditions ranging from good growing conditions to wide temperature variations along with drought conditions and in some cases extremely wet conditions. For soybeans, the main disease reported throughout Virginia was the Diporthe phomopsis seed decay complex. The Plant Disease Clinic in Suffolk received more of these samples than any other in 2020. The disease can be identified by dead stem tissue running lengthwise along the stem, black spots on pods, or as shrunken or discolored seed. Although growers lean on fungicides to control diseases during the season, good data on fungicides for controlling this disease is lacking. Some pathologists have mentioned they have seen some activity with Group 7 fungicides. Although some varieties tend to get this more than others, weather conditions between R5 and harvest tend to drive the epidemics. Rotation of other crops for 2 or more years can help, and planting different maturity groups or staggering planting dates can spread disease risk to ensure that all plantings don't experience favorable conditions during seed formation and maturity. Before I talk about fungicide efficacy, I wanted to remind folks that sprays between R3 and R5 have shown the greatest impact on soybean disease control and improving yields. Typically, it is recommended to apply fungicide if cool, wet conditions persist in the R3 to R5 growth stages. If it is hot and dry during these stages, a fungicide application is generally not warranted. Fungicides labeled for foliar disease control in soybean are in FRAC group 11, 3, and FRAC group 7. These fungicides have different levels of systemicity to some degree. They have various spectrums of activity and the diseases they control. The only group that has kickback activity or activity after symptoms are seen are those in FRAC group 3. Most of these are available as premixes that are able to capture the individual strengths of each fungicide while broadening the spectrum of control. The risk of resistance development of these fungicides is medium to high, so premixes help reduce risk of resistance development as well. This is some data from 2019 showing fungicide efficacy of various soybean fungicides against foliar pathogens like Cercospora leaf blight and frog eye leaf spot. The higher the bar, the more the disease observed in plots. Here is the untreated check showing the highest level of disease. Notice here that Quadris, a QOI fungicide or group 11 fungicide, has a high level of disease similar to the untreated check. My predecessor, Dr. Mell, conducted research that showed that resistance in the frog eye leaf spot pathogen to this chemistry was widespread in Virginia and that QOIs or FRAC group 11s applied alone may not be effective. DMIs in FRAC group 3 like Domark and Tilt typically provide the most consistent control of the FRAC groups in most trials like this one. Overall, most fungicide premixes offer significant disease control compared to untreated plots, and disease control and yield differences among these fungicides is hard to detect. This slide shows disease severity of fungicides applied at R3, R5, or both R3 and R5. These data indicate that R3 sprays are generally as good or better as sprays at both R3 and R5. That combinations of fungicides are superior to standalone products, and that the FRAC 3 fungicide Domark does exhibit some kickback activity when applied closer to disease onset. When we look at the yield data from this trial, we really don't see any major yield advantage of the R3 sprays with the exception of Quadris Top SBX. Other than Quadris applied alone in Miraval's Top, most R5 and R3 plus R5 treatments did provide a substantial yield advantage over non-treated plots. In fungicide efficacy trials conducted by Dr. Mell between 2017 and 2019, Miravis Top and Preaxor plus Domark provided good control of frog eye leaf spot while maintaining good yields. Most fungicides were fair to good on Cercospora leaf blight, while Miravis Top was the only fungicide that provided anything on improving seed quality. Quadras Top SBX consistently provided the best yields of the fungicides mentioned. In summary, fungicides are not likely to be profitable under dry conditions. If conditions are normal to wet, fungicides applied between R3 and R5 may increase yields. Don't spray frac group 11s or strobilurins alone due to fungicide resistance problems. Generally, Domark applied alone is an effective and economical fungicide application. Among premium fungicides, Quadras Top SBX is most effective. Overall, don't expect fungicides to prevent issues with seed quality. The most observed foliar disease of corn this past year was gray leaf spot, and we also saw some of the new disease, curvularia leaf spot. Gray leaf spot is characterized by lesions that run along the veins, and they appear boxed off on the ends. Curvularia leaf spot is mostly a cosmetic disease, and it appears as tiny necrotic spots surrounded by a yellow halo. In one of our fungicide trials at the station in 2020, we compared fungicides applied early at the V5 stage versus fungicides applied at the usual time around tasseling. These data represent disease severity of gray leaf spot, with the highest bars indicating the most disease. You can see again that the highest bar is the untreated check. You can also see that most treatments applied at tasseling, which are the orange bars, were more effective at controlling gray leaf spot than treatments applied at the V5 stage, which are the blue bars. One exception are applications of Lucento and TopGuard, which effectively control disease regardless of the application time. While we did see up to twofold increases in disease control, no yield advantage was observed between any of the treatments. For disease control in corn, I stand behind the basics of crop rotation and planting resistant varieties. These two control measures will do more to reduce disease losses in corn more than anything else. Most fungicide applications will perform better when used at the tasseling stage. However, Lucento and TopGuard EQ may open that window to spraying earlier. Conditions in much of the Commonwealth were favorable for fungal diseases of wheat in 2019 and 2020. Incidents of powdery mildew and leaf rust were sporadic in fields, but leaf and gloom blotch and fusarium head blight or scab were fairly widespread. Overall, these are consistently the two most important fungal diseases of wheat in Virginia. As many of you know, fusarium head blight or wheat scab can produce the toxin DON, which can result in dockage or rejection of wheat. Fungicide trials have been conducted in the U.S. through the U.S. Wheat and Barley Scab Initiative to determine which fungicides are most effective at reducing DON. Of these fungicides, Proline alone and the combination product Miravis Ace have shown the greatest promise in reducing DON levels by 45 and 60%. DON can also be reduced by as much as 30% with tebuconazole or as much as 20% with TILT or propiconazole. Data on this slide represents control of leaf blotch and powdery mildew for fungicides applied at flag leaf and at flowering. As you can see, most fungicides do a pretty good job at controlling both of these diseases. Control of either disease is typically better when fungicides are applied at the flag leaf stage. Wheat yields in this trial responded well to fungicide treatments, with all treatments out-yielding non-treated plots. The greatest yield advantage in this trial was demonstrated by Miravis Ace and TILT applied at flowering, and Preaxor TILT along with Approach Prima applied at flag leaf. This slide illustrates the stages of wheat from flag leaf or boot stage through flowering. The boot stage, or Feast stage 10, It's when flag leaf is fully developed and the head is visible when you peel back the leaf sheath. Feats 10 through 10.5 is when the head emerges until the head is fully emerged. Flowering stages occur when the first yellow flowers appear about midway up the leaf and until all the head has flowers from top to bottom. Traditionally, most fungicide sprays that control Fusarium head blight target the flowering stage. This slide represents Fusarium head blight control provided by Miravis Ace applied from heading to late flowering compared to Caramba Prosaro applied at the traditional time of flowering. Miravis Ace significantly controls Fusarium head blight compared to the check when applied at all 4 application times. This implies that growers have a larger window to apply this product and still achieve acceptable levels of disease control. Yield data from this trial shows a corresponding significant increase in yield improvement with all timings of Miravis Ace. However, reducing DON levels was comparable to other fungicides used in the trial, with really no advantage in suppression of DON levels with any fungicide or fungicide program. I encourage growers and farm advisors to use the Fusarium head blight risk predictor model provided by Penn State. This system uses the environmental conditions in your area coupled with varietal resistance to Fusarium head blight to calculate the risk of disease that can aid in making fungicide spray decisions. The website's pretty easy to find. Just type in wheatscab.psu.edu and your browser should take you to the web page where you can type in your specific information. So for Fusarium head blight of wheat, start off by selecting the best adapted Fusarium head blight resistant varieties for your area, followed by making timely fungicide applications. Typically, all fungicides are more effective if applied between flag leaf and flowering. If disease pressure is low, make a single application at flowering. For Fusarium head blight and DON, applying fungicides at early flowering and up to 1 week after flowering is most effective. Use the Fusarium head blight risk tool I mentioned, especially for premium fungicide like Miravis Ace is planned. Now I'm switching gears to nematodes. Nematodes are subterranean organisms that feed on plant roots and disrupt water and nutrient uptake, as well as predispose some plants to disease. They're basically microscopic worms. Above ground symptoms appear as uneven, poor growth, or plants that appear stressed or yellow, or have some type of nutrient deficiency. The roots are really where you need to look, and symptoms can appear as swollen or galled roots, exhibited here with root knot nematode feeding, pruned or stubby roots caused by external nematode feeding, or the female nematodes themselves, like these white cyst nematodes on the surface of the root. Damage from nematodes is more severe in soils that tend to be prone to water stress or have poor fertility or other negative soil characteristics. In general, nematodes exacerbate stress conditions, and their damage is more evident when pre-existing poor soil conditions exist. In the nematode lab, we use 2 types of nematode assays. The diagnostic assays are usually taken in season when a grower sees poor growth or other stress symptoms in the crop. This tells you if nematodes are causing a problem being observed. Those are usually collected from the bad spots in the field. The predictive assay determines the risk of nematodes affecting the crop you will plant next growing season. These samples are taken just after the previous crop has been harvested and are usually from samples taken all over the field and combined into one composite sample that represents the entire field. Economic thresholds are used for various nematodes on different crops to determine if nematode management practices are needed. The first table contains thresholds for both the sedentary or immobile nematodes that we see, root knot and soybean cyst. Notice here that root knot affects all 4 crops, but has a different action threshold for each crop. Since all 4 crops were affected, this shows the difficulty in rotating away from root knot nematode fields to lower their numbers. Soybean cyst nematode is specific to soybeans and has a relatively low threshold due to the high reproductive nature of the nematode. However, since corn, cotton, and peanuts are non-host crops, they can be used in a rotation to reduce cyst nematode populations. The second table represents threshold labels for migratory or mobile nematodes. Typically, stubby root is more damaging than your lesion nematode. And sting nematode has a low threshold because as few as 10 or 20 sting nematodes in 500 cc's of soil can cause severe damage, especially in sandy, coarse-textured fields. Several management tactics must be employed together for successful nematode management. Good sanitation means cleaning equipment from one field to another and destroying root residue that harbors nematodes from one season to the next. Crop rotation lowers populations by introducing a non-host crop. Practices that minimize drought stress and improve soil fertility can mitigate losses, and some cover crops can be used that lower nematode populations between seasons. Host resistance is a mainstay when available for root knot nematodes like root knot and cyst. Pesticides are typically our last line of defense as seed treatments and in-furrow applications. But successful nematode management integrates all of the above. Don't expect pesticides to bail you out of a high-pressure nematode situation. You'll be very disappointed. Let's take a look at the available pesticide seed treatments on soybeans. You've got synthetic products like Avicta that contains abamectin and Alevo that contains the fungicide nematicide fluopyram. You also have biologicals like BioST, Cloriva, and Poncho Vetivo that are primarily based on biological materials. These are all listed in the Virginia Pest Management Guide for field crops. This table illustrates the yield response of soybeans treated with these nematicides over several years in fields with low, moderate, and severe nematode pressure. Avicta is the most consistent performer with an average yield of 3.4 bushels per acre increase over untreated plots. And this is over 11 trials. However, in some trials, yield was at or below that of untreated seed with Avicta. The other seed treatments give less consistent yield results. Overall, seed treatments mainly provide early season protection, but early season protection is important. Sometimes plants never reach their potential if damaged early. Sometimes nematode damage that occurs later negates the early season benefit of seed treatments, especially in high pressure fields. Typically, seed treatments are inconsistent and flat out don't work in fields with high nematode populations. Host resistance is more effective, and combining host resistance and seed treatments in medium to high pressure situations can be very beneficial. The cost of adding a seed treatment is a consideration when doing this. Once again, it's a case-by-case basis or field-by-field decision. It's not something that you do whole scale on your entire farming operation. It's a very different decision-making process compared to making the decision to apply a fungicide. Periodic updates with disease management information can be found with the Virginia Ag Pest and Crop Advisory blog. If you have questions or comments about my presentation, feel free to contact me via email or by phone. I typically have my cell phone with me, and it's the best way to contact me if you need a quick answer. Thank you very much for your attention.